We're going to draw out all possible carboxylic acid and ester isomers for C5H10O2 in this video. Before we begin, how many isomers do you think we will get? In fact, there's quite a few. So do stay tuned until the very end of this video. Let's get started. Carboxylic acid has a carboxyl functional group, which is C double bond O connected to an OH. Note that this carboxyl group is always at carbon 1 for carboxylic acid. Ester, on the other hand, it has a carbonyl group connected to an O, and that O is connected to a C. So the difference between carboxylic acid and ester is, in carboxylic acid, after the O, there's a H. In ester, after the O, there's a C. So let's start with carboxylic acid. Since we have 5 carbons, let's place the COOH group at the beginning, and then we'll add in the remaining carbons in a row like this. That's our first carboxylic acid isomer, having a 5 carbon chain. It's 5 carbon chain because there are 5 carbons connected straight in a row. Now, instead of placing all 5 carbons in a row, we can place 4 in a row, and then we will stick the 5th carbon like this on carbon 2. This will give us another isomer. And if we were to stick the 5th carbon on carbon 3, we will get yet another isomer. Now, what if we were to stick that 5th carbon on carbon 4? Yep, you guessed it. We'll actually end up with the first structure. So we've already drawn that out, so scrap that. Since we are done with the 4 carbon chain, let's now move on to 3 carbon chain. So we will place the remaining 2 carbons on C2 like this. And we can't shorten this 3 carbon chain to 2 carbon chain anymore, so looks like we are done drawing all isomers for carboxylic acid. Let's fill in the structures with hydrogens. Keep in mind that each carbon makes 4 bonds, and be sure to check to make sure that every structure has 10 hydrogen, no more and no less. Just a quick recap on how we drew the 4 structures for carboxylic acid. We started with 5 carbon chain, and then we move on to 4 carbon chain. We got 2 structures by placing the 5th carbon at different parts, C2 and C3. And once we've exhausted the 4 carbon chain, we then move on to a 3 carbon chain. This is a systematic way of drawing isomers. That way, we won't accidentally miss out on any structures. Alright, now let's move on to esters. For ester, the functional group is COOC. So let's start by placing it at the beginning. We've used up 2 carbon and 2 oxygen. So for the remaining 3 carbon, let's place them after the COOC group like this. And that will give us a 1 plus 4 combo. Retaining the 1 carbon at carbonyl group, let's shorten the 4 carbon chain after oxygen to 3 carbon. And then we'll place that extra carbon on the first carbon after oxygen. This will give us another isomer. We can also place that extra carbon on the second carbon like this. And this is another isomer. Before we move on, we can further shorten the chain after oxygen like this. And that should wrap up the series. Let's now move on to having 2 carbons on the carbonyl group. Here we have a 2 plus 3 combo. We can shorten the chain after oxygen to 2 carbon like this, and that will give us a 2 plus 2 combo. Since we can't shorten the chain any further, we are going to move on to 3 carbon on the carbonyl group. That gives us a 3 plus 2 combo. We can't shorten either chain, so let's move on to 4 carbons on the carbonyl group. So that gives us a 4 plus 1 combo. Since we have 4 carbons on that carbonyl group, we can actually shorten that to 3 carbon with the extra carbons sticking in the middle like this. So we've drawn out 9 isomers for ester. Let's finish up by adding the hydrogens. Don't forget that each carbon makes 4 bonds, so make sure you check to make sure that every structure has 10 hydrogens. To recap, we have a total of 4 carboxylic acids and 9 esters for C5H10O2. Hope this systematic way of drawing isomer is helpful to you. Just a quick disclaimer. The numbering that I use on the structures, those are not meant for naming. It's actually just to help us see how many carbons we have on each side of the structure. That makes it easier for us to keep track when drawing the different isomers. If you're interested in drawing other isomers aside from carboxylic acid and esters for C5H10O2, let me know in the comments and I'll post a video for it. I hope the video helped you out somehow. Do subscribe and thanks for watching.